Hello guys, in this video I am going to explain preparation reactions of alkanes. Let's see one by one. First method is reduction of alkyl halides. In this, generally reduction means addition of hydrogen. We will add the hydrogen by removing more electronegative atoms like oxygen or halogens. Let's see one example here. If we have this RX alkyl halide, here in this method we will use a reducing agent for reducing this one. Reducing agent. Generally, reducing agent. We will get RH. We just need to replace this. We just need to replace this halogen with hydrogen. This is all about the reduction of alkyl halides. Let's see some important reducing agents which we are used mostly in organic chemistry. Commonly used reducing agents. If you remember these reducing agents, it's enough for organic. Mostly we will use these reducing agents only. So let's see one by one. LiAlH4, lithium aluminum hydride. You can write it as LaH also, and NaBH4. And one more thing is red phosphorus H2. Red phosphorus plus H2. And we will use reducing agents mostly zinc, zinc plus acid, CH3COH, and zinc plus NaOH. Or we can use this H2 hydrogen in metal catalyst. And one more thing is TH3 SNH, triphenyl tin hydride. This one also we can use. This can be written as TPH. In this, you have to remember these. This one and this one and this one are strong reducing agents. Strong reducing agents. Here NaBH4 is mild reducing agent. NaBH4 doesn't reduce the primary halides. Let me write here. Let's say this is primary halide. If you add NaBH4, this reaction won't occur because NaBH4 doesn't reduce the primary halide. And we have one more case for LiAlH4. Let's see that one. In case of LiAlH4, if you take primary and secondary alkyl halides, then you will get alkane. Here we are taking LH. But when you take as tertiary halide, then you take tertiary halide, then you won't get alkane. You will get alkenes here. This is one you should remember. Remember these reducing agents. And let's see the another method for reduction. Let's see the another method for preparation of alkanes. That is reduction of acid or carbonyl compounds or alcohols. We can reduce these groups in order to get alkane. Let's see one example. Let's take an alcohol plus. Here we will take reagent as reagent red phosphorus oxide. This is the strongest reducing agent. So it can reduce all these groups, acid, carbonyl compounds, and alcohols. It will reduce all these groups. 2HI, red phosphorus. You will get alkane. And if you see for carbonyl compound, let's see one example for carbonyl compound. Let's take one ketone or C double bond O R dash plus. So it takes 4 moles of 4HI and in the presence of phosphorus, you will get R dash alkane. So in this way, acid also gives you alkane by using this reagent with phosphorus plus HI. Let's see that example also. Let's take acid HI with phosphorus plus HI. You will get RCH3. Here we have one carbon, like alkyl group and one carbon. So you will get this alkane. But this method is not that good. These yields are not that good as compared to other methods. So we won't use this method more. Let's see the another method for preparation of alkanes. Third method is reduction of carbonyl compounds. In this we have two methods, Clemmensen reduction and Wolff-Kishner reduction. Generally in Clemmensen reduction, reagent, you should remember this reagent. In exams they will ask directly like in between reactions, we will use these two methods very often. You need to remember these reagents. For Clemmensen reduction, reagent is zinc H3 HCl. And for Wolff-Kishner reduction reagent is NH2 NH2 N2, or else you can write like this also, N2H4 KOH, or you can write like this also, NH2 NH2 in the presence of base KOH. Clemmensen reduction is in the presence of acid. The Wolff-Kishner reduction is in the presence of base. So Clemmensen reaction is acid sensitive. Means if you have any like if the molecule contains any acid sensitive group, then we need to take this Wolff-Kishner reduction. Let's see one example for Clemmensen reduction. Alright, C double bond O. Here it is Clemmensen reduction, so we will take zinc HG HCl Then you just need to remove this C double bond O. Just remove this double bond O and write. Okay. And this Clemmensen reduction is, and one thing you should remember is this method is not used if the molecule contains any acid sensitive group. If that molecule contains any acid sensitive group, then we should use this Wolff-Kishner reduction. Let's see that one. Let's see one example for Wolff-Kishner reduction, and then I will explain you with one acid sensitive group. Let's see one example. RC double bond O. Here we will use N2H4 KOH as reagent. This you should remember. For Wolff-Kishner reduction, we will use this reagent. So you will get RCH2 R dash. Same thing you have to do. You just need to remove this double bond O, like we did in Clemmensen reduction. These both these both reactions are same, but reagent is different. That you should remember. Let's see one example in which molecule contains acid sensitive group. Let's see one example which con- let's see one example in which the molecule contains acid sensitive group. Let's take this example. C double bond O, CH3, and we have this OH, which reagent is used. Here in this example, we have to use Wolff-Kishner reduction because this molecule, this substrate have one acidic hydrogen. See, let's see here. It is an acidic hydrogen. So we should use Wolff-Kishner reduction. So N2H4 plus KOH. Then we will get the product. Just remove this double bond O and we will get this product. Let's see another method, fourth method. That one is catalytic hydrogenation of alkenes and alkanes. Here in this method, we will use the reagent as reagent hydrogen H2 in the presence of platinum or palladium, or else we can take nickel at high temperature. We can take that one also. Then nickel, we can call it as the you can use any one of them. Let's see an example. If we have this alkene CH2 double bond CH2, then if we add this H2 platinum and the presence of heat, we will get alkane CH3 CH3. Likewise for alkyne also, from alkyne also we will get alkane in this way, in the same way. Let's see an example for that also. CH triple bond CH. From alkene also we can prepare alkane by using this H2 platinum in the presence of heat. Then we will get alkane. This reaction is also known as a Sebastian-Anderson reaction. You can call it, you can call this reaction as Sebastian-Anderson reaction. Anderson reaction. So this mechanism is also called concerted mechanism. If you want to know the detailed mechanism for these, then let me know through comment section. Or else if you have any doubt after seeing this video, then just write in the comment section. I will definitely go through the comments and I will clear your doubts. Let's see another example. And you have to remember one thing here, hydrogenation is synation. This is important. Hydrogenation is synation. Synation means addition of hydrogen in the same side of carbon. Let's see from this example. CH2 double bond CH2. Here, in the presence of hydrogen, platinum, and heat, we are getting CH3 CH3. We are just adding hydrogen by removing this one of the bond. So, we are adding that hydrogen on the same side like this. This is called synation. So, we should remember this point. Hydrogenation is synation. So, let's discuss another method. That one is fifth method. Alkanes from Grignard reagent. This is more important. We will see this reactants, this method mostly in organic chemistry. So let's see one example. Here Grignard reagent is RNGX. This is the most like we can say famous reagent in organic chemistry. That is Grignard reagent. You can write this as R minus MgX plus. This Grignard reagent is strong base as well as strong nucleophile. Strong base and strong nucleophile. If we have any acidic hydrogen in the compound, then it will abstract that acidic hydrogen in order to get that alkane. Let's see an example. If you have this Grignard reagent, CH3 minus MgX plus, if you have this water here, H2O, then you will get here. You can write this water just like this H4. Here, this CH3 need to extract this hydrogen, then you will get CH4 methane, CH4 plus Mg4HX. You will get this product. This way you can do the remaining things like if you have Grignard reagent and it will extract acidic hydrogen for forming this alkanes. Methane. Let's see more examples in this. If you have CH3 plus Grignard reagent plus NH3. Here also you have acidic like hydrogen. Here this you can write as NH2. Here also same process. This will extract this hydrogen and you will get alkane. In this way If you have alkyne, like let's see an example with alkyne. If you have this alkyne plus R minus NaOH, let's say, this here this R minus abstract this hydrogen and you will get RH. In this way, you will get we can prepare alkanes from original reagents. Let's see another method. That one is sixth one from hydrolysis of carbides. Here we have only like two reactions. I will explain those two. Those are C2C plus in the presence of water, we will get methane plus BeOH taken twice. And from Al4C2 also, if you add water, then you will get, sorry, CH4 here, CH4 methane plus KLOH taken twice. You will get these. You will get alkanes from these two. These two are also called as methanites because we are getting methane from this, so we can call it as methanites. Let's see the another method. That one is decarboxylation of acid. This one is a simple and important one. We will use this one like very common organic. Let's see the reagent. Reagent is important in this method. We will use this NaOH, CaO in the presence of heat. We will use this reagent in order to get the alkane from acid. So let's see an example. R C double bond O OH. Here we have this acid. We have to use this reagent here, NaOH, CaO, heat. Then we will get alkane RH. Here CO2 will be released. This is also called soda lime decarboxylation. Let's see another method. Eighth method called by electrolytic method. Let's see its mechanism for decarboxylation of acid. It will be very simple. Let's see its mechanism here. If you have this R C double bond O minus Na plus. After treating RC double bond OH with NaOH, you will get this one RC double bond O minus Na plus. And we have OH minus also in this reaction. So this OH minus will attack on this carbon and this bond moves shift towards oxygen. Then we will get R C O minus Na plus. And here also you get O minus Na plus. And here it is OH. Then after simple rearrangement like this, O negative will comes here and it will form bond with carbon and oxygen, and this R group will be removed. Then we will get R minus plus OH C double bond O minus in your place. From here, from here, this R minus abstract this hydrogen, then we will get alkane RH. This is simple mechanism. Let's see another method for preparation of alkanes, that is coal-based electrolytic method. Let's see an example. CH3 C O minus, or else you can write like this also. C C double bond O. Let's see an example. CH3 C double bond O minus Na plus. Upon electrolysis, you will get alkane CH3 CH3. Generally, in this reaction, we have to take 2 moles of this. Let's see one example here. Generally, you will take alkyl halides, 2 moles of alkyl halides. 2 moles of alkyl halides in the presence of sodium and dry-ether. For Wood's reaction, we will use this reagent, sodium and dry-ether in the presence of dry-ether. We will get alkane R plus NaOH. Here we will take this 2 moles, so we will get R. Here you have to remember one thing is we will get only given number of carbon. Like we won't get, we can't prepare methane from this because we are taking 2 moles, so we can't prepare methane from this. This is all about preparation of alkanes. If you have any doubt, then let me know through comment section. I will definitely clear your doubts. And, this is the part 1 of the alkanes. I will upload part 2 and part 3 for this alkanes chapter. If you like these videos, do share with your friends and help them in organic chemistry. So thank you guys for watching this video. I hope you learned about alkanes.